We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus, in which we are pursuing a discussion, and we have reached to a point where we are able to calculate the spherical surface area into a spherical coordinate. Surface area of a sphere, surface area of a sphere in spherical coordinate system through conventional way. What is conventional way? If I have a position vector, what is position vector? Position vector is a vector that connects origin and any particular point P. If coordinate of a particular point P is x comma y comma z, then the position vector is xi plus yj plus zk. If position of a particular point is r sine phi cos theta, r sine phi sine theta, r cos phi, then position vector is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. This is called position vector. If I have a position vector and position belongs to a line, derivative of position vector will be another vector, and that will be along the line. If line is not a straight line, then it will be at that point, it will be tangential along the line. Okay, if this is a straight line and this is point P, this is position vector, this is origin. Now, if I take derivative of this position vector, it will result into another vector that will be along the line. Or if this is a curve, then if this point is point P and this is position vector, then differentiation of this position vector will give another vector that will be tangent at this point. Everywhere it will be tangent. I mean, it really will be tangent at every point. Okay, so this proves that the differentiation of position vector is the another vector that is along the line. If position vector represent a point that is on surface, then differentiation of position vector will be surface vector. People can say it surface area vector. Mind blowing, amazing. So through conventional mathematics, conventional calculus, what is the surface area vector? Surface area vector is d of position vector. If position vector represent a curved line, then d of position vector. What is position vector? Xi plus yj plus zk. D of position vector means dxi plus dyj plus dzk. This is the this is called line vector. If position vector represents a area, then area dxi plus dyj plus dzk is the area vector, whatever it is. It depends upon that x comma y comma z point represent what. Anyway, this is conventional mathematics. Now, if I talk about a spherical coordinate system, then a spherical coordinate system has three independent variables. One is radius, one is phi, and one is theta. Okay, if there is a spherical coordinate system, what are the three variable coordinates in Cartesian coordinate system? Then it is x, y, and z, where x represent a length, y represent a length, and z represent a length, and they are at 90 degree to each other. What are the three variables in cylindrical coordinate system? Then it is theta, r, and z. Okay, where z represents a length, r represent a length, but theta represent an angle. Okay, if it is a spherical coordinate system, then it is r, theta, and phi, where r denotes a length, whereas if I say what is the unit of r, then it is meter. Meter and direction. Vector is strength and direction. Okay, what about theta? Then it is radian. What about phi? It is radian. It looks little funny that a spherical coordinate system, all three independent variables, they are not length. Two are angle and one is length. I believe it is alright. But when we are trying to calculate area vector in spherical coordinate system, it is again d of position vector. If I try to show position vector in a spherical coordinate system, then what will be a position vector? Okay, I'll take out a kind of a sphere again. I have another sphere, and that is quite big and quite heavy. Okay, I have another sphere. Okay, I have another sphere, and it is quite big and quite heavy. It is quite big and quite heavy. Okay, if this is a sphere, then what are the three variables we are talking about? If there is a center of this sphere, if this is a sphere, then there will be a center of this sphere. From the center of the sphere, if I take out a line touching any point on the surface, if this point is P, that is x comma y comma z, from center of it, inside it there is a center. From center, consider that center is the origin. This is centered at the origin. From the center, if I take out a line, that is, take out a line that is passing the P, then that is radius. Okay. Another is from the center, if I see the horizontal plane, from center horizontal plane, if I move the radius in angular fashion, that angle is called theta. And from center, if I keep this radius vertical and move in a vertical plane at angle, that angle is called phi. These are the three independent components in the spherical coordinate system. Now, if I talk about any point P here, these are not mentioned in any of the book, what I am going to talk now. If I talk about any point P here, if I talk about any point P out here, what is the position of this point? If it is Cartesian coordinate system, that is x comma y comma z. If it is Cartesian come spherical coordinate system, hybrid model, then it will be r sine phi cos theta, comma r sine phi sine theta, comma r cos phi. Whatever if this point P when it is pure spherical coordinate system. In pure spherical coordinate system, to denote a point P, I have to take three variables, that is r theta phi in a length, because it talks about length. It doesn't talk about the angle. If I talk about the length, the radius will be r. That is all right. What about theta? Theta. Theta is angle. And what about phi? That is angle. Now, if I move like that, if I try to move like that, now if I on horizontal, if I move this radius theta, then the length that correspond to theta is the arc. If I move radius in vertical plane, the length that denotes the phi is r. Means if I try to denote any point P here, then if I talk about length, then radius is the length. If I talk about theta, then it will be the arc. And if I talk about phi, then it will be the arc. Altogether, what will be the coordinate at that point? Now consider that I have radius at angle phi and angle theta. Okay, how come it can be at angle phi and theta? Consider this is 0 degree on horizontal plane. This is origin and this radius is at 0 degree because this is theta at 0 degree. Now it is at theta degree on horizontal plane. Now I am bringing it up. Now from vertical plane it is at phi angle. Now if I move like this in vertical plane, making the phi variable, keeping the theta constant and phi variable, then whatever the arc we are getting, that is r into phi. If phi is 0, there is no arc. If I moved phi, then what arc it made like this? Okay, whatever arc it made like this arc is r phi. Now, if I say r sine phi, then it will directly fall on horizontal plane where it is had made angle theta. Okay. Earlier the resting point is theta is 0. Now I make theta angle, move it like this. Now it makes phi angle with the vertical. Sin r sine phi will fall on the horizontal plane. R cos phi will go back to the vertical. R sine phi will fall on the horizontal plane. Cos theta will be x-axis. Sin theta will be y-axis. This is this is something that is kind of hybrid model, whatever it is. Now we are talking about how to get point P. Point P, one thing is sure that radius is r. If I talk about vertical arc, then it is r phi. R phi. Then one more I got it, that is r phi. If I make r sine phi, it will fall on horizontal plane. Then if I move like this, then only theta will move. R sine phi theta. Okay, if I move little bit, whatever angle I have moved, accordingly it will form arc on the horizontal plane. If whatever angle I have moved in vertical, accordingly it will make arc in vertical plane. Arc in horizontal plane is r sine phi theta. Arc in vertical plane is r phi. Okay, if phi is 2 pi, then r into 2 pi, that is 2 pi r is the vertical plane circle circumference. Anyway, now these three are orthogonal to each other if I talk in the length, but mind it that independent variable are r, theta and phi. But the phase of theta and phi as a length is concerned, theta and phi are angle. If I say that, okay, can you show me theta and phi in length? Then r sine phi theta is the arc for the theta and r phi is arc for the phi. All three lengths are perpendicular to each other. The vertical arc is perpendicular to the horizontal arc everywhere. If this is horizontal arc, then vertical arc will cut it at 90 degree. And this radius will cut the vertical arc at 90 degree. Okay, radius, if I make it fall on horizontal plane, then radius will again cut horizontal arc in 90 degree. All three cut at 90 degree. Means it fulfills the requirement of being a coordinate system. In coordinate system, all three variables length vector should cut each other at 90 degree. If I take a cylindrical coordinate system, then also theta means r into theta, that is the arc it makes in cylindrical coordinate system. R theta, r and z, all three cut each other at 90 degree. Anyway, so position vector in spherical coordinate system, position vector in spherical coordinate is too heavy, maybe I believe 5 kilograms. Okay, the kind of a position vector in a spherical coordinate system here is, if I start with the r, then it is r vector or r into r unit vector, or I just say x, y, z, then it will be r from center, that radius is r comma r sine phi theta comma r phi. R phi is the vertical arc, r sine phi theta is the horizontal arc. Thank you very much. Okay, then what will be the position vector? Position vector from origin, if I draw a vector, what will be position vector? Then position vector will be r into r unit vector. These are not available in any of the book. R unit vector plus r sine phi theta into theta unit vector plus r phi into phi unit vector. Okay, if you watch previous video, there we have deduced that if d, small d of position vector, derivative of position vector is area vector, then that can be represented as d of p by dxy, I'm sorry, d theta phi into d theta phi. Anything, if I have x, then x equal to x by y into y. I can divide by same thing, multiply by same thing. Means if I have d of p, it is same as d of p by d of theta phi into d of theta phi. D of p by d of theta phi means if I have a xy plane, if I have a xy plane, if I have a xy plane and on xy plane, I'm sorry, I have a theta phi plane. This is a theta phi plane. On theta phi plane, I have the sphere that is kept on theta phi plane. I have the sphere that is kept on theta phi plane. Okay, in that sense, if now this sphere, consider this sphere is centered at the origin. This sphere is centered at the origin, means half of the sphere is above the theta phi plane and half of the sphere is below the theta phi plane. And the blue color here is the origin, means the center of this coincide the blue color anyway. Now if that is the case, then if I take any point here on this plane, if I take any point theta comma phi, if I take any point theta comma phi, from that point, if I make a rectangle from that point, if I move along theta as theta plus delta theta, and I move along phi as phi plus delta phi, then I have made a small rectangular change there from theta comma phi point as theta plus delta theta comma phi plus delta phi. There is another point called theta plus delta theta comma phi plus delta phi. That is a rectangular region from point P. Okay, I believe, consider there is a point here called P. This P is a point on theta phi plane. If I make a dp by d theta phi, dp by d theta phi, I make if one unit of area change in theta phi plane, how many of in area change I see on the surface. If this is a point P here, this P corresponds, if I take down a straight line, it corresponds to a point on theta phi plane as theta comma phi. From theta comma phi, it go and touch a point here, that is theta comma phi, that is a point P here. Okay, in theta phi plane, if I move one unit of area, make one unit of area change, then in that one unit of area change, there will be innumerous point will come there, I can go and touch it here. If I collect all those points here, what will be the surface? Means for one unit change on theta phi plane, how many unit of change I see in the position vector area dp by d theta phi. If now concept is that here, if I take any point as theta comma phi and move here theta, move here delta theta and move here delta phi, then I have made a change at delta phi and delta theta in theta phi plane. Accordingly, on the surface, if there was a point P, then how much mapped region, because if there is a theta comma phi, then mapped region is a point there called P. If I make delta theta comma delta phi area on theta phi plane, what will be the mapped area there? That area, if I calculate that area and divide by delta theta delta phi, it will be exactly what change I see in the position vector area by one unit of area change in theta phi plane. dp by d theta phi. Okay, please watch our previous video. We have calculated it, and that is dp by d theta cross dp by dr into d theta phi. I'm sorry, that is dp by d theta cross dp by d phi into d theta phi, that is d theta d phi. So area vector is dp by d theta cross dp by d phi, bracket close, into d theta d phi. If that is the case, what is position vector here? Position vector is r unit vector plus r sine phi, r sine phi, r sine phi, I'm sorry, r sine phi theta unit vector plus r phi unit vector. Okay, by d of that by d theta, cross product, again same thing by d phi. Here if I do differentiation with theta, r will go away, phi will go away, only variable part is theta. So it will become r sine phi theta unit vector. If I do the derivative, r sine phi theta unit vector. There, if I do the derivative with the phi, r will go away. Another is r sine phi theta, theta unit vector. That will come as r cos phi theta, theta unit vector, plus r phi, then phi will go away, r phi unit vector. Now this side r sine phi theta unit vector, cross product with the r cos phi theta, theta unit vector, plus r phi unit vector. Theta unit vector cross product will go away. Theta unit vector, phi unit vector will call cross product as r unit vector. In that sense, it will become r square sine phi r unit vector d theta d phi. This is area vector in pure spherical coordinate system. Mind blowing, amazing. R square sine phi r unit vector d theta d phi, where r is constant. Okay, now can you calculate the surface area like this? Certainly. Okay, r being constant, I can keep outside. Sin phi integration with d phi will result in minus cos phi. Phi is 0 to 2, 0 to pi, 0 to 2 pi, minus cos phi, minus 1, it will become 2, 2r square. Integration of d theta will be theta, 0 to 2 pi, 2 pi. 4 pi r square is the surface area of a sphere in pure spherical coordinate system. Someone can try pure cylindrical coordinate system to find the surface area of a cylinder. Someone can try pure cylindrical coordinate system to find the surface area of a cone. No one stops anyone. Amazing, but it is very simple. If someone try Cartesian coordinate system, it is very difficult. How simple it is. Anyway, let's proceed through our pseudo multivariate calculus. If I'm trying to find pseudo multivariate calculus, then pseudo multivariate calculus, we know that what is length vector. Okay, cross product of two length vector gives the area. Okay, I'm trying to find area vector anyway through the pure spherical coordinate system. That is the concept. Consider this is an area. This is a rectangle. If this is the rectangle, this is one side and this is another side. What is the area of rectangle? Pseudo multivariate calculus. Try with the simplest thing. If I'm trying to find a sphere surface area, try to find a simple rectangle. Okay, then this width into this height is the area, or this vector cross product with this vector will be the area vector. How I entered from the width, this is width and this is length. W into L is the area. From W into L, how I came to vector, that is another story. Consider this is origin and this point is x1, y1. Consider this is origin and this point is x2, y2. Then this width is x1 whole square plus y1 whole square root. Length is x2 whole square plus y2 whole square root. If I say that width is a square root of x square plus y square, x square plus y, x1 square plus y1 square root, this is exactly the magnitude of a vector x1i plus y1j. If I say length is x2 whole square plus y2 whole square root, that is magnitude of a vector x2i plus y2j. Means if I represent this as a vector, magnitude of this vector into magnitude of this vector will give the surface area. If I say this is A vector and if I say this is B vector, then A vector's magnitude into B vector magnitude. A vector magnitude into B vector magnitude will give the surface area, that is width into length. If I say I'm not going to calculate magnitude of A vector, just A vector and B vector, then you have to do cross product. A vector cross product B vector, it will result into another vector and that is called area vector. Calculate the magnitude of area vector, you will get the area here. Now this is not a flat rectangle, this is a curved line. If it is a curved line, then this will become a curved line. the vector representation of this curved line cross product with the vector representation of this curved line will again give the surface area. This is called pseudo multivariate calculus. If I'm trying to find the surface area of a sphere has a curved surface. It does not have a flat surface. So for curved surface, if I take any part of the sphere, then one side of the curved surface is a curved line, another is a curved line. We will represent this curved line through a vector, and we will represent this curved line through a vector. How to represent a curved line through a vector? Please watch our previous video. To represent a curved line through a vector, okay, representing a straight line through a vector is xi plus yj. Okay, if this is x-axis and this is a straight line and this point is x comma y and this is origin, then this line can be represented as a vector as xi plus yj. If this is a curved line, instead if it is a curved line, then what is difference between curved line and this point is x comma y? If I represent through vector, then this will be direct this vector, not the curved line, curve vector. To what is difference between a straight? This is how pseudo multivariable calculus proceed. Where we are lagging, why I am not able to represent a curved line through vector? Because if I this is x comma y and this is origin, if I represent it as xi plus yj, then that will be a straight line vector. I want curve vector. Curve vector means everywhere a vector will be tangent to the curve. It will be set of vector. But one thing I see that if it is a straight line, then y by x, everywhere y by x is same. But if it is a curved line, everywhere y by x, y by x, y by x, everywhere y by x is different. Means y by x is variable. So our vector representation xi plus yj, I have to represent it in a form that y by x will come. If that is the case, then x I have to take outside. Then it becomes xi plus yj. X I have to keep outside. Then it becomes I plus y by xj bracket close into x. That will become same thing xi plus yj. Okay, if that is the case, then it becomes I plus y by xj bracket close into x. Now y by x variable factor is coming. Now it represents a curve vector. Means when we are trying to calculate the surface area of a curve, then this line is a curved line and it can be represented as I plus y by x bracket close into x. Similarly, this can be represented as a curved line. Now here, if I consider this as x-axis, this is y-axis, then here we will take out y, not x. Then it becomes x by yi plus j bracket close into y. Okay, now cross product of these two will give the curved surface area. What is that? That is I plus y by xj bracket close into x. Cross product with x by yi plus j bracket close into y. These two will give, because these are the representation of a curved line. This will give them. That's it. Okay, that is take a vector and take out x from one side, take out y from one side, that then they will represent a curved line vector. Do the cross product, you will get the surface area. Okay, if that is the case, then what about a sphere? Okay, if I talk about a sphere, oh, if I talk about a sphere any point P here, then I make a cut in xz plane, orthogonal cut, and then I make a cut in yz plane. If I make a cut in xz plane and if I make a cut in yz plane, then in xz plane it will form a circular curve, and in yz plane again it will make a circular curve. Now for a surface area that we are talking at point P, the two lines, this curve is a circle and this curve is a circle. One is in xz plane and one is in yz plane. For xz plane, if I see xz plane, then if I see the curve line vector, then it will be I plus y by xj, x I have taken out. Otherwise, for the position vector, if I talk about the position vector, then that is xi plus yj plus zk. Cross product with xi plus yj plus zk. One is in xz plane and one is in yz plane. I take out x from one side. it becomes I plus y by xj plus z by xk bracket close into x cross product with y by xi plus j plus z by yk bracket close into y. These two cross product will give the surface area of the sphere. Mind blowing, amazing. Let's try with the pure spherical coordinate system. If I take pure spherical coordinate system, then it is same. I make a cut in one plane, I make a cut in another plane. Then they are curved line. If this is a curved line, then what is curved line vector? What is the vector representation in a spherical coordinate system? R into R unit vector plus R sine phi theta theta unit vector plus R phi unit vector cross product with the r unit vector plus r sine phi theta unit vector plus r phi unit vector. From one side I'll take out theta, from another side I'll take out phi, so that this will become a vector representation for a curved line. Now if I take out theta from one side, it becomes r by theta r unit vector plus r sine phi theta by theta, that will go away. Then r only r sine phi theta unit vector plus r phi by theta phi unit vector bracket close into theta cross product with, I'll take out phi now, r by phi r unit vector plus r sine phi by phi theta unit vector plus r phi by phi gone, r phi unit vector bracket close into phi unit vector. Okay, let's do the cross product of these two. Now, before doing the cross product, this is pseudo multivariate calculus. I can take cross product, but it will be complex. Now, if I take pseudo multivariate calculus, then division will become differentiation and multiplication will become integral calculus. This is how we proceed in pseudo multivariate calculus. So r by theta will become dr by d theta, but r does not change with the theta. Anyway, for surface area, r is anyway constant. So r by theta, that is dr by d theta, that is 0. Now another is r sine phi theta unit vector, that will remain like that, plus r d phi by d theta. Phi also does not change with the theta, that is again 0. It becomes r sine phi theta unit vector into d theta cross product with the another one, that is dr by d phi r unit vector, that is again gone, r does not vary with the phi. Next is dr sine phi theta unit vector, that will by d phi, that will become r minus cos r cos phi theta unit vector plus r phi, because there is nothing there, r phi unit vector d phi. Altogether it becomes r sine phi theta unit vector cross product with r cos phi theta unit vector plus r phi unit vector d theta d phi. If I take cross product of these two, theta will go away, only theta and phi will remain in the cross product. Then it will become r square sine phi r unit vector d theta d phi. It is exactly same what we got through conventional mathematics. Means our pseudo multivariate variable calculus is amazing, awesome. Can you prove that it is really amazing, awesome? We will prove it. We will do more magic in the pure spherical coordinate system. We will not limit ourselves only the area calculation here, because we have got a big wealth of getting any mathematical solution starting from a simplest case. And now we got that area vector is r square sine phi r unit vector d theta dr. D theta d phi. Now start moving. Mind blowing, amazing. Please watch previous video, because there we have talked about Cartesian coordinate, their hybrid model of a spherical, and there it mind will be more open with those kind of examples. Mind blowing, amazing. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. 91 plus 91 is the India country code, 9483160610 is the telephone number.